Swayam Prabha. Digital India. Educated India.
Welcome to the second lecture of Mechanics of Materials course. In this lecture, we will get an introduction to linear algebra and then we will see how to use initial notations. First, let us assume that A is a matrix which will denote it by this symbol here. Let us say it has entries 1, 2, 3, 4, 5, 6, 7, 8, 9. And B is another matrix which has entries A, B, C, D, E, F, G, H, I. I am going to define some basic operations in linear algebra. Many of you might be knowing this already, but for completeness sake let me go ahead and define those operations. When I say A, matrix A plus matrix B, what I mean is this resulting matrix 1 plus A, 2 plus B, 3 plus C, 4 plus D, 5 plus E, 6 plus F, 7 plus G, 8 plus H, 9 plus I. Okay. This is what this operator plus means. Okay. Similarly, if I want to multiply this matrix A times B, then what I mean is multiplying these columns with these rows. A multiplied by B means multiplying these columns with these rows. So, now what does this A into B means? A into B means 1 into A plus 2 into D plus 3 into G will be the first row, first column entry of this matrix A into B. The second entry of this would be 1 into B plus 2 into E plus 3 into H. The third entry of this row would be, it is going to be 1 into C plus 2 into F plus 3 into I. Similarly, for the second row of this A into B matrix, I have to multiply the second row of A with each of these columns of B vector, B matrix. So, it will be 4 into A plus 5 into D plus 6 into G. Similarly, the second entry is going to be 4 into B plus 5 into E plus 6 into H, and third entry is going to be 4 into C plus 5 into F plus 6 into I. The last row of this, I am sure you would have recognized the pattern by now, would be 7 into A plus 8 into D plus 9 into G, and here it is going to be 7 into B plus 8 into E plus 9 into H, and here is going to be 7 into C plus 8 into F plus 9 into I. Okay. This is what matrix multiplication means. Now, in A into B is not going to be equal to B into A. Let us see that. Now, I am interested in finding the result for B times A. This is not equal to A times B in general. Okay. To see what it means, let us write first row of B into A. B into A, what should I do? I have to multiply the rows of B with the columns of A. So, the first entry there is going to be B times A is going to be A times 1 plus B times 4 plus C times 7, right. When I multiply the rows of B, the columns of A, that is what I will have, in contrast to what you add for A times B. You can see the difference between A times B and B times A here. Okay. So, A multiplied by B is not same as B multiplied by A. I leave this as an exercise for you to complete what the entries of these are going to be. Now, I am also interested in finding what A transpose B would be, for reasons that will become evident towards the end of this lecture. A transpose B would be 1 2 A, this is A transpose 6 7 8 9, this is A transpose, that is I have to interchange the rows and the columns. A was initially 1 2 3 4 5 6 7 8 9 arranged along the rows, now it becomes arranged along the columns because I am interested in transposing this matrix A. Okay. So, B remains same, B is A B C D E F G H I. So, this gives me 1 times A plus 4 times D plus 7 times G is the first entry. Second entry would be 1 times B plus 4 times E plus 7 times H and so on. Okay, I leave it as an exercise for you to complete the remaining components of A transpose B. So, this is what this multiplication means. Okay. So, we have seen what addition of two matrices mean and what multiplication of two matrices mean. Till now we have been doing it by writing all the elements of the matrix and then we have been multiplying it and writing what the resulting matrix is. Now, say I am lazy or I do not want to explicitly state what the components of the matrix is, that is 1 2 3 4 5 6, but I want to deal it with some symbols like A B C that I have used. I am going to use an alternate symbol to represent the matrix A, as matrix A can be represented as A I J, where we will follow the convention that I means rows and J denotes the column of this matrix A. So, this would have been A 1 1 because I am in the first row first column, and A 1 2 because I am in the first row second column, and A 1 3 because I am in the first row third column here. Similarly, it will be A 2 1 second row first element first column, A 2 2, A 2 3, A 3 1, A 3 2 and A 3 3. This in a short form written as Aij. This matrix in short form has been written as Aij. Okay. Now, similarly, if I have a vector which I will denote it by this symbol A, this denotes a vector. It can, I will write it as a column vector A1, A2, A3, which I will denote it as AB. Okay. AB in general, I will not have this 1 to indicate the column. Okay. So, vectors will be represented using just one index. By default, vectors for us would be a column vector. Okay. Now, if I want to multiply this A matrix with this vector A, I know that it will be A 1 1, A 1 plus A 1 2, A 2 plus A 1 3, A 3, A 2 1, A 1 plus A 2 2, A 2 plus A23 A3 A31 A1 plus A32 A2 plus A33 A3. This equation I want to write it in short form by writing this A matrix as Aij and this vector A as Aj, and I am going to indicate that I have to sum this j from 1 to 3. This will be another vector, say this vector was equal to B, this will be the Bith component of the vector B. Okay. So, basically what we have is, you have here B1, B2, B3 represented as A11, A1, A12, A2. So, that is the same equation here, okay, where I can take elements from 1, 2 or 3. Okay. So, basically this matrix vector multiplication can be represented as this. Now, I am going to become a little bit more lazy and say that, simplify the equation that I wrote there. I wrote Aij Aj equal to Bi, j equal to 1, 2, 3, and I takes elements from the set 1, 2, 3. I am going to rewrite the same equation, dropping off the summation symbol, saying that if an index is repeated twice, if an index is, index means I or j or b what we use for a b, what I write in a suffix is called as the index. Okay. If an index is repeated twice on the same side of the equal to symbol, then it is called as dummy index. And by default it has to be summed from 1 to 3. Okay. In contrast, this index I, which appears on either side of the equal to sign, is called as a free index. If an index, for example I in the above equation appears only once on either side of the equal sign, the index is called free index. In contrast to dummy index, this is called as free index here. Okay. It is called as free index, and it should not be summed from 1 to 3. Important word is it should not be summed. Dummy index has to be summed from 1 to 3, whereas a free index should not be summed from 1 to 3. Okay. In this example, j is a dummy index and I is a free index. Okay. Now, why is this dummy and free have to be distinguished? Is a dummy index can be given any alphabet, it can change into any other symbol, okay. Just like a variable can be denoted by x, y or z or t or a, this dummy index can be changed consistently throughout into any other symbol. J can become b, j can become k, but j cannot become I because I appears on either side of the equal to sign, okay. So, except for the indexes that appear on either side of the equal to sign which are free indexes, the dummy index can take any other symbol also, because by default you are going to sum that from 1 to 3, okay. So, this dropping off of the summation sign is a convention that we are going to adopt, okay. So, what that means is an index should not appear more than twice on side of the equal to sign, okay. If the index appears more than twice on one side of the equal to sign, there is something wrong with your initial notation. This is called as the initial notation of this matrix equation, okay. This is called as the initial notation of the matrix equation. Matrix multiplication is initially denoted by in this particular form here, in this particular form here, okay. So, now let us understand how to write matrix multiplication. Say I have a matrix A which I write it as Aij, and another matrix B I write it as Bab, okay, where Ij denotes the components of that matrix 1 1, 1 2, 1 3, 1 4 like that. Now, I want to define a matrix C which is A times B. Then what should I do? I have to sum the columns of A with the rows of B. So, this J and A have to be of the same symbol. So, this means by our notation this has to be Aij, B J B would be C I B, okay. So, going back to our equation that we had here, this is C A B. So, C 1 1 corresponds to this term, right. That is, we are multiplying the column indexes of A with the row index of B, okay. So, let us go back and check whether we are getting the same thing for this matrix, okay. So, let us do it the long way. So, A would be written as A11, A12, A13, A21, A22, A23, A31, A32, A33, right. This is what this means. Similarly, B would be B11, B12, B13, B21, B22, B23, B31, B32, B33. Now, this is going to be equal to C11, C12, C13, C21, C22, C23, C31, C32, C33, which in terms of A and B would be A11, B11 plus A12, B21 plus A13, B31. The second entry would be A11, B12 plus A12, B22 plus A13, B32, okay, plus there will be additional terms. These two terms are suffice to see that what we are summing up is in a given this thing, this if I write C11 here, C11 would be summation A1 j B j1 j equal to 1 2 3. Let us see whether this is equal to this, right. So, I have 1 1 here, so it is 1 1 here, 1 1 here, 1 1 here, and j has been summed from 1 2 and 3. So, this corresponds to C11. Similarly, C12 would be A1 j B j 2 summation j equal to 1 2 3, which is 1 and 2 here. The 1 and 2 here corresponds to 1 and 2 there, 1 and 2 there, 1 and 2 here, and then j has to be summed from 1 to 3, which it has been 1 2 and 3, j has been summed. So, you see that this is the short form notation of doing a matrix multiplication. Okay. I can write it succinctly as Aij Bjb. Okay. So, let us now continue to see how will I write this following multiplication. I want to do A transpose B is C matrix. So, how will I write C I B as is the question. I know that A is written as Aij and B is written as, this B matrix is written as B A B. Okay. Now, since it is transpose, I will sum the A transpose would be A j I, and this I have to multiply with B A B. So, now multiplication means I have to make these two indexes the same. So, it will become C I B would be A I j B j B. Is this right? No, if I write it like this, I want to use the fact that I have interchanged the indexes I and j here. Okay. So, this is not right. The correct expression for this is A j I B j B would be C I B, because I have to interchange these indexes. Okay. So, this is the right way of writing A transpose B. Let us examine that. A transpose would be A11, A12, A13, A21, A22, A23, A31, A32, A33. Here the meanings of the indexes are changed. So, that is why the first index is the row index. Okay. First index has come like this multiplied by B, which will be B11, B12, B13, B21, B22, B23, B31, B32, B33. If I multiply this, what do I get? The first term would be, okay. So, if you multiply these two matrices, what you will get is A11 B11 plus A21 B21 plus A31 B31. The second entry would be A11 B12 plus A21 B22 plus A31 B32 and so on. So, if you see now C11 would be AJ1 BJ1, this 1 1 has to repeat at the end. The column index of B and A should be the same. You can see that it is the same here. The column and the indexes of A and B are same, whereas this J means you have to sum 1 2 3, which you are doing on the row index of A and B. Okay. Similarly, C 1 2 would be A J 1 B J 2. So, the column index of A has to be 1 and the column index of B has to be 2 in the second term. Okay. You can see here the column index of A is 1 and the row index of B is 2 as suggested by this expression here, and you have to sum j from 1 to 3, which are doing by summing it from 1 to 3. Okay. So, basically now this what A transpose B means, basically you change where you add the repeated index, where the dummy index comes changes from A multiplied by B to A transpose multiplied by B. This is important because in many places you will be using this concept of initial notation in this course. Okay. Now, let us move along and understand what a difference between a vector is. Now, we have seen matrix multiplication